Good morning to you all. I am René Garello, and I'm sorry not to be present with you. And I'm presenting today a part of the R8 Climate Change Committee that we at IEEE are handling. You see the names of the members of the committee, and my specialty being about the ocean. I'm going to talk about the ocean sustainability. So within the Climate Change Committee, there are three initial core: green energy, food security, and oceans, which I'm developing. And the action to be adapted for climate change and climate engineering initiative within Region 8 are listed here, and mainly to have the possibility to create interdisciplinarity and integrate the specific technologies and disseminate these technologies and methodologies. So, ocean sustainability and the impact of pollution. What is being done to detect and measure the impact, for instance, of marine debris, including plastic, and to have the preservation of marine ecosystem. This is part what I'm going to present of a seminar, a webinar that we did with the United Nations. And you see that the United Nations now agrees that or recognize that the ocean plays a crucial role in the achievement of sustainable development goals. Of course, there is an importance of the ocean. We have listed here a few of them, like of course creating jobs. It's a primary production. It's also a carbon storage, but we have to be careful about that. And you have also food security and etc. and transport and tourism, not to speak of them completely. The impact of the human activity on the ocean is very large because 30% of all the CO2 emissions are finally ending in the ocean, creating more problems, as I was saying before, like acidification, of course, a lot of excess heat energy of the ocean at the surface being the engine for the hurricane, and so the hurricane are stronger, not more numerous, but are stronger. Of course, this implies that there is a sea level rise, deoxination, coral bleeding due to the acidification, and I was just talking about it, the storm formation. And on top of that, the man-made pollution, like, of course, the plastic that I was talking about, the oil due to the tankers and the cleaning, let's say, so to speak, of the tankers, and the impact to health that is through pollution and viruses. In terms of marine debris observations, first we have to assess the relevant data. So there are all the plastics and others similar are coming from the land and are very often coming back, so to speak, to the beach and the shoreline and the shoreline. So we have also the floating marine litter and what is let's say disposed of by ships and boats, and including the nets, which are lost sometimes. And this plastic decays in smaller pieces, micro, nanoplastic, and are ingested by the marine life, and it's a source of problem for the health in the end. So we have, as IEEE, we are technology oriented, and we have plenty of means of observation, either from below the surface with autonomous vehicles or moored vehicles, or moored station, at the surface, of course, with boats, and everything is transmitted back to satellite and to data centers, and we have also satellites to make observation of the surface. So a diversity, a lot of diversity of means of observation. What are the associated challenges? First, in terms of observation, we have the 90% of the plastic goes through the rivers. So we can measure or have an estimation of the concentration of plastic particles and the amount. And we have also direct measurement of the motion through remote sensing, either in situ, based on land or on the ocean, and of course through satellites. So far, there is no existing standards to describe the level of marine litter and pollution. So we really need the implementation of monitoring and removal that follows some kind of standards, and that is something that we are working with the UN Environmental Programme because of this deficiency combined with a lack of awareness is a major reason why the problem of the marine litter remains. It's known, it's better known now, but it's still not completely understood. So we have these needs for standards. IEEE is also a standard organization, and the kind of definition, a standardized methodology is necessary to ensure the comparability and consistency of the data which are collected. So that goes through management group, technical of course, and the activity of groups, again in technical domain. That means that we have to develop criteria and methodology standards in order to be completely shared by everyone. And it's a directive. And a joint international coordinated infrastructures has to be identified, has to be created. So the idea that was put in place by such entities like GOOS, which is a Global Ocean Observation System, is to have a process-driven approach. It works quite well with processes that are meant to achieve a highly efficient implementation of the monitoring and removal system. So on the one hand, you have data, on the other hand, the issues, and it commonly shared are all these means of observation that I was referring to before. So on top of that, we must add the numerical models, and which are fed by in situ observation. And on this slide, you can see the compilation of in situ observation and the fact that they are related to places where the model is also detecting, or let's say proposing concentration of plastic through gyros and let's say once you have the model that is evolving, it goes to the places where you have the in situ observation are collecting the most observation of plastics. So the model then can predict where the plastics will end in terms of concentration. In terms of processing, the approach is now more and more through a data-driven description more than a theory-driven. And because we have so much data that using artificial intelligence is not exactly that, but the mathematical and signal processing part under artificial intelligence, which is deep learning, for instance, that is having the system learning before doing something, that we can ingest what is collected as data into the models and back to the data in this kind of sort of data model loop. The challenges, as a summary, that remains are first the question: how do we observe that? Something that is has been the object and the subject of a white paper from the United Nations Environmental Programme, and is available. It's a publication led by Emily Smale, to which many people participated, and was the aim was to develop an information platform for monitoring the marine litter and marine debris, and develop some action. The second question that we can have is, how do we integrate all the observation? I was developing that fact that we had in situ observation, we had also satellite observation, underwater observation, surface observation. So the diversity of the sources is important. The diversity of communities using this data is also very important, because we have the marine science people, we have the technology like IEEE people, we have the citizens as well. The outcome of the research can be also regionally oriented. It's not the same way to collect plastic in different parts of the world. And on top of that, we have the diversity of data processing, because there are platforms. There are also processing which is done at the sensor level or after, that is at the data center. We have a need of calibration between the sensors, and we have a need to manage everything. So that, again, a possibility for the artificial intelligence to have a role there, not for giving the answer after we ingest everything to the artificial intelligence and say, okay, do it, but we have also to monitor what the artificial intelligence has learned through the mechanism of learning, machine learning, deep learning, as I was saying, and we have to have a control from the human. The next slide, which I show in a few seconds, is a kind of absurd situation, and I show. Okay, it's from a Gary Larson, who was. Few more slides. What kind of application could we have using all this diversity of sensors and data? One that comes to mind, in my mind, because I've been participating to the committee of the sea cleaners, is the construction of this kind of gigantic boat, which is called here the Manta, and have the information of where the plastic are in regions of the world where we know there is still a lot of, let's say, litter sent directly to the river. So not to pick anyone, but around Indonesia and the Philippines, there are lots of floating plastics. And so the guidance here that I'm referring to is to have the models, like you see on the left, the information from satellite about the currents, the buoys, about also the currents, some other types of satellite that can give the motions, and altogether this is sent to the boat that goes where the plastic is floating. And so to finish, thank you, merci in French, for your attention. On the left, you see the plastics are rejoicing because they are going to be there forever. And on the right, you see that it's a second degree humor, that the invasive species are not really the one we think about, but we are the invasive species. Thanks again, and have a good day.